Japan's Thin test has quite recently impacted the world forever, with its wonderful score on the moon. Japan has turned into the fifth country to land a spacecraft on the moon. The huge undertaking, which was years in the making, highlighted new, cutting-edge technology that might change space exploration as far as we might be concerned. However, in the midst of the excitement, something dim and secretive was seen about the test, something that has everybody talking. It turns out there was much more to this mission than the world at any point realized. What happened to the test on the moon? What secrets have been uncovered about this mission, its valid reason, and its effect on space exploration? Join us in this video as we uncover everything about Japan's moon lander mission. We at last track down what NASA was concealing. On January 19, the Japan Aerospace Exploration Agency, JAXA, handled its extraordinary test, Thin, on the moon. This amazing accomplishment made Japan the fifth country ever to land a vehicle on the moon successfully. The project started as far back as 2005 with building a small lunar landing test satellite. By 2013, Thin had been proposed as one out of 7 core missions for the ISS. Fast forward to April 2016, Thin became an official JAXA project, with Mitsubishi winning the award for building the rocket. The main point of the mission was to test a new arrival technology. The project, if successful, would feature an exact pinpoint landing strategy that would greatly influence space exploration moving forward. Thin's excursion to the moon took about 4 months. The journey began with a ride along the Dark Imaging and Spectroscopy mission, DART. After separating from DART, Thin took an alternate route, preparing to enter into lunar orbit by December 25, 2023. It effortlessly entered lunar orbit and adjusted with possibly one of the most amazing moon landings ever seen. Moon landings have always faced a significant issue, arriving at the perfect place. The smart lander for examining the moon, Thin, was a concept that aimed to utilize new, modern technology to accomplish an ideal moon landing. The success or failure of the mission would let know if the space exploration community had a better approach for landing entirely on the moon or any other planet. The focus for NASA and other space organizations has long moved from landing anywhere on the moon to landing precisely at an explicit point. Fortunately, the mission came to a productive leap forward on January 19 when the lander made a very exact, delicate landing on its objective area. However, despite the fact that the test landed delicately, there was a power issue due to the way the test had handled its solar charger, which should have been pointing toward the sun but was facing another bearing. As such, there was absolutely no way for Thin to recharge. JAXA's ground team had to utilize the backup batteries to send 2 rovers to take measurements of the lunar surface. Moreover, the multi-band spectroscopic camera, NBC, mounted on Thin was able to capture images. Due to the data gathered from the gadget, JAXA was confident that the lander hadn't endured any significant harm after landing, so they chose to leave the test on the moon and wait until after the sun changed its position to face the solar chargers. Just so you know, 1 lunar day is 14 Earth days, meaning that if you were on the moon, it would require 14 whole days for the sun to rise and set. Initially, JAXA had planned to operate the test for at least 2 weeks, exploiting solar power. However, after the surprising accident, all that was left to do was to pause for the rest of the lunar day. By then, the sun's beams would point in the direction of the solar charger, and JAXA would finally have the opportunity to harness power for the test. This approach, described by the Japanese in this mission, has shown that it is feasible to make extremely exact landings on the moon. Moreover, they've also demonstrated it is possible to make a delicate landing on the moon, something that has proven difficult even for organizations like NASA. One thing NASA didn't do during its Apollo missions was land on target. For example, Neil Armstrong and Buzz Aldrin endured difficulties while handling the Apollo 11 lunar module. First, there were serious communication issues with the base, and then a wide range of alarms went off. Overall, it seemed like the automatic landing systems had failed, and Armstrong had to take manual control to land the module. That being said, they landed in a totally wrong area. The fact that Thin arrived on target is actually a significant plus. Most endeavors to land on the moon recently have resulted in failure. Generally, when tests attempt to land on the moon, they crash. Besides, they crash in spontaneous areas. Japan's then, however, managed to execute a delicate landing to such an extent that the rovers could still be sent. Just to give you an idea, imagine what might occur if a rocket suddenly loses one of its motors mid-flight. Worst-case scenario, it would fail spectacularly. Best-case scenario, it would make an emergency landing in a quick, helpful landing spot. But you see, although the test lost its nozzle, it still landed spot on. This has earned Japan a truly impressive position among individual nations that have ever considered exploring the moon. Up until this point, only China has made a successful moon landing in the 21st century. It is still a question why 21st century moon tests can scarcely nail a landing while, 50 years ago, NASA was landing astronauts on the moon. Many cynics have raised questions regarding why this is the case, and some established scientists have come up with possible explanations. First, in those days, there was a space race. The US and Russian governments were arguing furiously. Every nation made a good attempt to prove its dominance over the other, and the space beyond our planet was the battlefield. NASA, fully supported by the US government, poured in lots of resources to create the best lunar landers and rovers. Today, there isn't a space race in the same sense. All countries that have finished lunar missions have done so basically out of interest or to cover a name for themselves throughout the entire existence of space exploration. Thus, the tests or space vessels of today are finished utilizing unsatisfactory materials to limit costs. In addition, most landers are worked by private organizations. Genuinely speaking, landers operated by privately owned businesses have a 100% failure rate on the moon. The ice-based Japanese lander, which crashed on the moon in 2023, is a genuine example here. Another factor that causes issues for landers and space tests is the moon itself. Communication on the moon is a huge issue since the giant white satellite generally slows down radio signals. This causes difficult problems and is generally liable for the cases where tests land in the wrong spot. Again, the lack of atmosphere on the moon makes it impossible for a craft to land with parachutes. Everything depends entirely on the engines. The pilot or control must figure out how to guide the test slowly to land while dealing with communication issues. Finally, if the test is too heavy, a crash is inevitable. China's Chang'e 3 lunar mission in 2013 was the first soft moon landing since Russia's Luna 24 in 1976. Most other landings from other countries, like Russia, have met a worse fate. Thus, it was about time someone thought of a solution for all the landing issues. Fortunately, Japan came to the rescue. The Japan Aerospace Exploration Agency, JAXA, has been a well-established partner of NASA. There's no doubt that the new Japanese guidance system would prove useful for future NASA missions. The Artemis program, for example, which is scheduled to have the next set of humans on the moon since the Apollo missions, is definitely going to include some of this historic technology. However, there is a big issue. Something bizarre happened to the Japanese lander, and JAXA hasn't been able to figure out why. The test, which was painstakingly designed to land upright on its objective, ended up landing face down. Theories suggest that this accident was caused by an external force. Unless this mystery is solved, there will be no guarantee that future NASA missions will turn out successfully. So, what exactly happened to the lander on the moon? Right now, it's still a mystery. This JAXA test was built to land in a very precise way. For instance, its legs were equipped with fold zones to ensure it executed a soft landing even when reaching at a higher speed. The target area where this craft was supposed to land was a 15-degree slope in an impact pit known as the Shally Pit. The test landed exactly at the coordinates 25.2 degrees east and 133.5 degrees south on the slope, just 55 meters off target. This spot was chosen to offer the most sun exposure. The test's back legs were constructed to be shorter than the front legs in order to accommodate the slope. Once again, JAXA modified the vehicle to flip at an angle of 45 degrees just before touchdown to achieve a gentler impact. It also boasted 2 Mitsubishi engines and 12 attitude control engines. Generally, lunar tests are required to have multiple engines to enable a smoother landing. Engines also play a significant role in limiting the descent speed. The landing was designed to be in two phases. First, the landing engines and a smaller engine would be activated to tip the rocket onto its side. Next, the 5 crushable aluminum landing legs would engage to cushion the final touchdown. In essence, the lander had everything it needed to make a smooth landing. Tragically, it ended up landing on its nose, and no one knows why. One surprising theory is that extraterrestrials might be involved. JAXA admitted themselves that one of the lander's engines failed just before making contact with the lunar surface. So far, as they know, the cause was an external factor. In other words, something likely altered the engines, causing the test to crash land. What could be on the moon that modified the lander's engines? Could this same external factor be responsible for the various other lunar crashes? Some conspiracy theorists, who have long believed in the presence of outsiders on the moon, suggest that these beings are sentient. However, this is just speculation based on the mystery surrounding the event. The established fact remains obscure. All JAXA knows right now is that the lander is facing west. For the present, not much can be done for the test unless, of course, the sun shines on it again. The only way JAXA can find out what really happened is if they can observe satellite imagery from something like NASA's Lunar Reconnaissance Orbiter. However, compared to most other 21st-century moon landings, the lander mission was an achievement in itself. The level of accuracy executed during this mission deserves commendation. In previous missions, landing sites or targets were marked in kilometers, and even then, many barely hit the target mark. For this mission, however, JAXA estimated the landing site in meters, and the lander hit the mark, veering off by only 50 meters. Again, the lander was able to send back 2 exploratory rovers and utilize as much onboard scientific equipment as possible before its battery ran out. The 2 rovers, which were named Lunar Trip Vehicles, LTVs, were unique in their own right. While LTV-1 is a frog-like rover that moves with hopping movements, LTV-2 is a small rover that splits into a wheeled camera and waggles along like how sea turtles do on a beach. LTV-1 managed to communicate properly with ground stations and also received a test radio wave data transmission from its counterpart LTV-2. However, JAXA hasn't received any pictures from LTV-1 yet. LTV-2 was the rover that captured an image of the lander on the moon. From the picture, it can be seen that the engines of this lander were facing upwards when they should actually be facing downwards. For now, both of these rovers are on standby, waiting for the days when the sun will shine on them again. If our estimations are right, the lunar day will be nearing its end around January 31st, so LTV-1 and LTV-2 should resume activity around this time. Just to let you know, the lander cost an incredible 88.118 billion yen, or $120 million, to create. In total, it weighed 200 kilograms with a weight of 700 kilograms after being fully loaded with fuel. The fuel here was essential to power the engines during the landing process. LTV-1 and LTV-2 were demanding components of the mission, both financially and technologically. LTV-2, for instance, has been renamed Sorik because of its complexity. The 0.25 kilograms rover was developed collaboratively by JAXA, Sony, Tomy, and Dashisha. At present, the littlest and lightest Wanderer, made about the size of a baseball, was developed utilizing a mix of toy innovation, sensor technology, advanced mechanics, and JAXA space innovation. It was intended to act independently and adapt to the lunar climate. Addressing the press, THIN's project administrator, Shet Rai, said, "We've demonstrated that you can land anywhere you want, rather than where you can. This will inspire an ever-increasing number of Japanese missions to attempt to land on neglected places on the moon." There's no doubt that this is clearly a win for the Japan Aerospace Exploration Agency, JAXA. With this new technology, perhaps space agencies will finally be able to send probes, rovers, or even astronauts to the far side of the moon. The far side of the moon, also called the dark side of the moon, is one area that has always been shrouded in discussion and speculation. Many rumors and theories about the presence of extraterrestrials on this part of the moon have emerged over the years, from the odd designs and shapes scattered across the surface to bizarre radio interference and strange crashes from lunar missions. There's a mystique about this side of the moon that seems to captivate the imagination. At one time, there were reports that NASA had sent astronauts to the far side of the moon, only for them to find a crashed spacecraft. Reports claim they brought back extraterrestrial cadavers for study. However, NASA has since denied such allegations, insisting that the last uncrewed mission was Apollo 17. JAXA's recognition on the world stage has been increasing since it became a trusted global partner for NASA and the European Space Agency. One significant project the organization contributed to was the International Space Station, ISS. Japan also signed on to assist in building several modules for the Lunar Gateway. Amidst this, JAXA has been planning its own missions. The thin landing is just one of many missions to come. For instance, JAXA is planning to visit Mars very soon. The Martian Moon Exploration spacecraft is set to launch sometime in 2024. This probe will make an excursion to the Martian moons Deimos and Phobos to collect samples and data. For this mission, JAXA will use its Epsilon H3 launch vehicle. The H3 launch vehicle is a two-stage rocket that utilizes liquid oxygen and liquid hydrogen as fuels. The first stage is powered by 3 engines, while the second is fueled by a single engine. The first time the H3 rocket was launched was in March 2023. It went well initially until the rocket failed to ignite for the second stage upon command. As such, the test launch was a disappointment. The next planned flight is likely to be around February 2024. However, something much larger than the H3 is currently being assembled, which will be used for Mars 2. It's called New Glenn. New Glenn is an immense launch booster. The 98-meter-tall rocket is powered by 7 engines on the first stage and 2 on the second. This allows the Glenn to push almost 50 tons of payload into Earth orbit. The first flight of the New Glenn is scheduled for around August 2024, and it will carry NASA's Artemis Mars mission into space. NASA is finding a bold way to launch this rocket, despite the fact that it has never been tested with such a heavy payload before. All of this demonstrates that space exploration is evolving and becoming more exciting every day. With Japan's advanced landing technology and NASA's ambitious missions and launches, there's no doubt that the future looks bright for upcoming space missions. This raises one question: did Japan send a probe to the moon to explore advanced planetary landing technology, or was there something else at play? Well, there's another obvious reason why the Japanese may have sent Thin to the moon: to investigate space-based solar power. On January 11, the U.S. Space Agency published a study examining the possibility of setting up solar power collection via a spacecraft in Earth's orbit and transmitting that power back down to the surface using microwaves. The goal here would be to create a source of clean energy. Even though the actual costs associated with the assembly and launch of these systems are still being estimated, many experts are considering the potential. If it works, it could help the US and other countries that adopt it achieve net zero greenhouse gas emissions before the deadline. You see, collecting solar energy in orbit is something entirely different from gathering solar energy on Earth. Up there, the Earth's atmosphere is nearly non-existent, so you're essentially getting the purest form of solar energy. The idea of harnessing such unadulterated energy and remotely sending it to even the most remote areas of the planet is quite captivating. Many space agencies, including NASA and JAXA, are making efforts in this direction. The solar power technology featured in Thin has already provided more than enough data for these agencies. Generally, all that remains is for NASA or anyone else to build on what Japan has done, leading to the ultimate solar power collector.